Hi everyone, and welcome to part 2 of Calculus Lesson 5-4. We're talking about work today. Now, our next example is about Hooke's law. It's about stretching a spring. So it says the force required to maintain a spring stretched x units beyond its normal length is proportional to x. So they've given you this for a force function. But notice they have two variables here, k and x. K is the spring constant. It's a positive constant that will be dependent upon the spring. And there are lots of different things it's dependent upon in a spring. So it could be whatever it's made of. It could be how tightly the spring is wound, how thick the wire is. So each spring is going to have its own K value. So we need to find that out for whichever situation we're working in, and then we can write this function. So this is going to be similar to that last question we did, except we have that extra step of finding out what K is. Another thing to be careful about is the units that they give. Remember, distances in meters or feet. You can't have any other measurements other than those, so we have to be careful when we're plugging things in because springs tend to be small, so we don't normally measure them in meters and feet. So let's take a look at an example. Okay, example 3 says a force of 40 newtons is required to hold a spring that has been stretched from its natural length of 10 centimeters to a length of 15 centimeters. How much work is done in stretching the spring from 15 to 18 centimeters? So the first part of this gives you a value for force, and it also gives you a length change. Okay, and x represents that length. So we have 40 newtons for force, and we know it's been stretched 5 total centimeters. But wait a minute, that says centimeters. I need to change that. Okay, so our force is 40, so I have 40, because notice it says force equals K. K is what I need to solve for. And it says x is how far it's been stretched. But remember, I need these in meters. Okay, so there are 100 centimeters in 1 meter. So I just have to divide both of these by 100. So I get 0.15 minus 0.1. Okay, so this is how many meters it is. Okay, so this is 0.05. So I have 40 equals K times 0.05. And now I just have to divide to get that value. So on my trusty calculator, I have 40 divided by 0.05, which is 800. So K is 800. Okay, so now what I'm going to do is I'm going to take this and put it into my work integral. Okay, my force is K times X. So I have 800 times X dx. And I need the integral. Now I need to look at what we're given here. It says from 15 centimeters to 18 centimeters. So in my integral, I need to figure out how far beyond the natural length of 0.1 this is. So 0.1 subtracted from 0.15 is 0.05, and 0.1 subtracted from 0.18 is 0.08. So those are my values in my integral. Now I'm going to do my antiderivative. So this is x squared, and this is 400, and I need to evaluate it from 0.05 to 0.08. Okay? Now in my trusty calculator, I'm going to do that. So I have 0.08 squared minus 0.05 squared. I'm going to hit enter, and then times 400. And that is 1.56. Okay, and we are working in newtons. So this is in Newton meters, also known as joules. So it's 1.56 joules. Okay? So that's it for that example. Let's look at our next type of question. It's known as a cable problem. Okay? So with cable problems, we're still looking at work. Okay, we're still looking at everything that's going on with work. But generally what's going to happen is we need to find the weight per unit of length. So a lot of times they'll give you a total weight of the cable, and you need to divide to find out the weight per unit. So generally what they're going to do is they're going to have a cable suspended over the edge of a building. For some odd reason, they do that. And then they're going to ask you to find the amount of work to reel it in to the top. So in this example, I have a 200-pound cable that is 100 feet long and hanging vertically from the top of a tall building. How much work is required to lift the cable to the top of the building? Okay, so step one in this is finding the weight per unit of length. Now, notice we're in pounds and feet. That's good. So my units are correct. And you always should check that before you start a question. Okay, so I have 200 pounds for every 100 feet. And I just need to divide this to find the weight per unit of length. So this equals 2 pounds per foot. Okay, so now I'm going to set up my integral. In my integral, I have 2, okay, times the length, dx, and I'm reeling the entire cable in, so it's from 0 to 100. Okay, so what we've essentially done is we've taken our cable and chopped it up into little tiny pieces that are 1 foot long. Okay, we've chopped it all up, and this is how much each of them is going to weigh. That's the force on it. And x is going to represent our distance, and it's varying from 0 to 100. Okay, so now we're just going to do our antiderivative. Okay, and it's just x squared evaluated from 0 to 100. And I just have to do 100 squared, which is 100 like that. So it's 10,000. And then subtracting 0 squared. So it's just 10,000 for this one. It's 10,000 foot-pounds of work. Okay, that's it for this video. I'll have another video with the volume question next. So come back soon.